In this lecture, we'll talk about the graph of logarithmic functions. First, let's have a review. So, the logarithm function is the inverse function of exponential functions. In our case, let's have an exponential function first. Then we'll see why log is the inverse. First, we have an exponential function y is equal to a to the power of x. To calculate the inverse function, we need to calculate x in the expression of y. Let's call it g of y. In order to calculate that, we have x is equal to log with the base of a of y. Therefore, the inverse function, then we change x into y and y into x. Then we have the inverse function f negative 1 of x is equal to log a of x. Note that how the y here becomes the x here, since we're changing x to y. Okay, let's have a brief summary of what's above. So the inverse function of fx is equal to a of x is f to the negative 1 power of x. It's not the real negative 1 power. It's to denote that this is the inverse function. The inverse of the power function is the logarithmic function. Okay. Then we're equipped to do the following section, the graph. In order to draw the graph of a function we haven't seen before, it is always good to see what's the graph of the inverse function. So, when we are drawing the graph of our new function that we haven't seen before, we can use the graph of the ones we know and flip it around the axis of y equal to x, and we get the graph of the inverse function of that. Let's have an example. If we have a function like this, when we are trying to draw the inverse function of this green line, we flip it around the edge y equal to x. Then the inverse function of the green line is exactly this. So these two green lines are symmetric to each other around the axis, about the axis y equal to x.